Now, let's turn our attention to determining the mass of magnesium or potassium bromide, KBr, that can be produced quantitatively. The theoretical yield is a 100% conversion of the reagents that are both used up. That is, that there is no starting reagent left over unreacted. Let's go back to the table to determine this theoretical yield.
Okay, back to this table, and you remember that 5 grams of potassium gave a mole of 0.128 because we took 5 grams divided by the molar mass, 39.1, and then we related it to the amount of magnesium bromide in terms of moles. Because this is a 2-to-1 relationship, we were able to get 0.064 moles of magnesium bromide, which then when you multiply it by the molar mass, it gave 11.8 grams of magnesium bromide. This is the amount where both of these, when they're reacted, both will be used up, and we could prove this by saying that if 0.128 moles of potassium reacts with all of what's available in this box right here, then we subtract the amount that reacts, 0 will be left over. Now, to find the amount of magnesium bromide that reacts with all of this, we could set this up in an equation. And this equation would be moles of magnesium bromide reacted is equal to amount of potassium, the moles of potassium that's available, or that reacts, times 1 mole of magnesium bromide, because there's one of those, to 2 moles of potassium, is equal to 0.064 moles of the magnesium bromide. And we'll put this in the box, 0.064, and this is all going to be used up in the reaction, so there'll be 0 left over. And because we have both as 0 left over, there are no unreacted material. To find the mole of magnesium that could be produced in a quantitative yield, or 100% conversion, then we could say that because magnesium bromide and magnesium is 1-to-1, then we could just put the amount of moles that could produce is 0.064 moles of magnesium. And this relationship, we could either use either one, because they're both 0 left over, they're both limiting, and this will be 0.128 moles of potassium, because 2 potassiums to 2 potassium bromides give exactly the same number of moles. If you use magnesium bromide, then you have to multiply this by 2 to get this number. Just to prove this logic, we're going to use the mole of magnesium produced. Okay, so this is the amount that can be produced, is equal to the moles of potassium that reacted, which is 0.128, times 1 mole of magnesium, because there's one of these, to 2 moles of potassium. This gives you a 0.064 moles, which we got right here. Now what we need to do is we need to find the masses. In order to find the mass, you multiply the mole by the molar mass. So the mass of KBr that could be produced quantitatively is 0.128 moles of KBr times the molar mass is equal to 15.2 grams. And we'll put this in the box, 15.2 grams. To find the mass of magnesium that is produced quantitatively, we take 0.064 moles times the molar mass of 24.3. That number is 1.56 grams.